Now, it may seem like we've come a long way, but in fact, we haven't really even taken the first step. That's a really encouraging thing to say, right? Well, I mean, I don't want to get too far ahead of ourselves, but yeah, there is so much more. And this is basically an introductory level course. There's just the little things, just the little introductions. And it's really hard to do the whole show, don't tell thing. So I want to tell you guys a bunch of stuff, but I want to explain it. And so I have to show you. And that takes a long time. And there's just so much stuff here. And there's so much stuff that you have to do on your own. There's so much learning and putting stuff together. And oh, we're still doing stuff at the command line. We're still making it through. We made it through our activities section, and now this section is progressing with the CLI. And I can't even say it's like you're going to go from beginning to intermediate with the CLI, because this is still very, very basic stuff. So, like a lot of the behavior that I encourage, introspection. You need to be introspective about what's going on and how this stuff works and how it's all put together. And so the thing that you're interacting with, the thing that you're running on the command line here, when I type ls and stuff is happening at a meta level, what's going on there? That is the command interpreter. The program that is responding to your commands is called a command interpreter. And so I think we might have said it a few times earlier in the program, but we didn't really call attention to it. It's just like, this is the terminal, and you're gonna type in stuff. Well, like everything on Linux, there are different command interpreters. Generally, on a system, if you do cat/etc, because remember we mentioned that etc is the configuration folder. We're going to talk more about file systems later, but there's a special file in there called shells. And so you can see that, yes, this is your shell. And so you might hear the term command shell or Unix shell, or you might hear a security researcher say, I'm popping a shell on that remote system, meaning that they're getting remote access to the system. Strictly speaking, the command interpreter runs on the shell. So like the shell is the access to be able to run programs on the system, and the command interpreter is the thing that takes the text and passes it to the system to do stuff with it. And so there are lots of different command interpreters on the system. So there are lots of different shells, because command interpreter is a mouthful, and let's just say shell. And so one of the shells is sh. That's a POSIX standard. It's a Unix standard, in other words. We've also got dash, bash, and rbash on our Debian system. Now, on our Red Hat system, it's a similar story. We can cat etc/shells, because that's basically a POSIX standard. You can expect it on most Unixes, most Linuxes. So we can see we've got sh bash no login, and then sh and bash again in user bin as opposed to /bin. And then we've also got user sbin no login. So user sbin no login and /sbin no login. That's just Red Hat being Red Hat. Those are really the same files. It's just symbolic links or something. So really we've only got sh for POSIX standards, bash, and no login. Now the sh is the Bourne shell, Bourne, like Jason Bourne. But this like Jason Bourne, this shell has seen everything. So yeah, and bash is the born again shell. See, there's Unix. Unix just is filled with all kinds of humor like that. And so basically everything that they got wrong in the ancient, 1970s shell, they fixed in the born again shell. Although a lot of people don't like either one of those, and so other command shells that are popular are K shell, C shell, TSCH, and also Z shell. And so Z shell actually is probably my personal favorite. If I have favorites, I have to work on a lot of systems, so I don't always get to pick the shell that I'm using. Sometimes you can't do that by convention or your employer or whatever, but Z shell is a lot of fun. When you're a little bit more advanced, you can learn about Z shell. For this introductory course, we're going to stick to bash, the born again shell. So the command interpreter does a lot of stuff for you behind the scenes. A lot of the commands, well, not a lot of the commands, some of the commands that you're typing into the shell are actually things that the shell does. And the shell is also programmable and configurable. You can set up your preferences. You can have it remember your preferences. You can have it execute a file every time you log in to set up your preferences. And we're going to go through all of that. But it's important to understand that the command interpreter on the system is configurable, and it's not necessarily the same. And you never really know. Your command prompt is also customizable. You can see it's pretty similar on both of these systems just by convention. You can see that we've got the username you're logged in as @ and then the name of the system, and then tilde bracket $. Now this tilde will change. So if we go to /tmp and do ls, see now the little tilde is /tmp. The tilde is, on this particular shell, your home directory. And so if you do ls tilde, it'll give you the same as ls/home/ your username. So the shell is converting the tilde into /home/Wendell. This is called shell expansion. The shell is expanding the tilde into home Wendell. And so I ran the echo command, which just echoes whatever you give it. Oops, can't type either. So if I do echo hi, we can see it says hi. And if I do echo tilde, it says home Wendell and not tilde. And so what's happening here is that, which echo, /bin/echo. So before bash runs echo, it's replacing the tilde with home Wendell. So this is not something the Unix programs do. And this is a very important, really minor thing to understand, that all of the programs that you interact with don't expand special characters. That is the shell's job, and the shell will have to expand that to tilde. So if you were to write a script and you refer to tilde in the script, it's not necessarily going to expand tilde the way that you expect, because the command interpreter may not be running the normal way that it is. In this case, it's running interactively as opposed to running in a script where it may be running non-interactively. And so things don't always happen the way that you expect. Other shell expansion is wildcards. And so like if you're familiar with DOS, if we do ls-l, we can see this. We can do ls-D*, and we see we've got desktop documents and downloads. Now those directories are empty, but this is giving me the contents of the things that begin with the capital letter D, desktop documents and downloads. And so the D* has been expanded by the shell to be as if I had typed ls desktop documents downloads. Now if you are familiar with DOS, and you've done work on DOS or even PowerShell, this is subtly different from how DOS works. DOS, the command interpreter on DOS, does this expansion thing internally, and all of the programs support wildcards, and so all of the programs handle wildcards differently. If you have a directory that has a zillion files in it, it is up to the command interpreter to list out each one of those files and pass it to a program. And if you have a directory that has too many files, you will get an error from the program that you're trying to run that says the argument list is too long. And we know that the term argument, we learned that term already when we were talking about making directories and things like that. And so when the argument list is too long, that's a 200 level problem. That's a problem that's a little bit beyond this course. But when the argument list is too long, you've got to do some other things like break up the operation into pieces. Maybe you would, do the letter A or whatever, just files that begin with the letter A, so that only some of those are expanded or whatever you might have to do. And again, all of that is going to be up to shell expansion. So we'll do ls-l, and I'm interested in files that begin with a D or an E. I can just do ls-l bracket DE bracket star. And that will give me anything that starts with a capital D or a capital E. In fact, I could put anything in here. Anything that begins with a lowercase letter, A-E-I-O-U. I just get the A text file. So there's some fun. Maybe I just want a single character substitution. I could do ls-l D, and that will expand to documents, or D, or ls-l P question mark. No such file or directory, but I could do P question mark C or B star, and that'll give me pictures or public. If you're having trouble understanding shell expansion or how exactly it works, or having trouble predicting what the shell might expand, you can still use the echo command. You can just do echo p star and see that echo is going to, behave a little differently depending on whether you do the expansion. Now notice that when there's no matching files, that it does not expand, and it also doesn't do away with the star. So if I do echo p star with lowercase p, because there are no files in my directory right now that begin with a lowercase p, echo is going to return p star. But because I have files that begin with a capital P, when I do echo capital P star, I'm getting pictures and public. And that is because I'm on a case-sensitive file system. Sometimes you run into file systems that are not case-sensitive, and then in which case the lowercase p star will work. In general, though, on Linux systems, you can expect a case-sensitive file system. If you come from Windows or Mac OS, you know that there's not a case-sensitive file system set up on those systems by default, but just something to be aware of. It's another one of those little gotchas that's like, surprise, this thing is happening. And if you don't realize it, or you come from another system, this is why you're like, gosh darn it, this is super frustrating, and I don't understand why this is not working. And it's like, well, case sensitive. And that's because historically Unix was case sensitive. So the more you know. So I talked about the command interpreter and shell expansion and some of the other fun things that you can do. But did you know that you can also customize your login and customize your commands, and you can customize literally anything. So we can do alias ll equal ls-l. Needs to be in quotes. And if I type the word alias by itself, I can see that ll is equal to ls-l and alias ls is equal to ls-color equal auto. So we do ls, get that, and we do ll. And then I get ls-l. Cool. That's neat. Alias can add things, which are neat, to help you with your life and make life easier and remember shortcuts and things like that. Especially if this is not a shared system. Like if you're logging into your own personal account, it's great. If you're using this in a business environment and you're not logging into your own account, like it's a shared account, you generally don't want to make these kind of changes, but there you go. All right, let's do a ls-al, and we can see on our Debian system here, we've got a .profile file. So we remember we can do a ls, and we can look around. And I would encourage you to look around your system. You should not be seeing these for the first time in this lesson. You probably should be poking around your system on your own and then saying, I wonder if he's going to cover that, or Control F searching through the notes on the course. I don't know. So .profile. At the top of the file, we got this handy, helpful comment that says it's executed by the command interpreter for login shells. This file is not read by bash if ~/.bash profile or ~/.bash login exists. See this example file for more examples. These files are located in the bash doc package. The default umask is set in etc/profile for setting umask for SSH logins. Install and configure the libpam umask package, umask 022, and then if running bash, if bash version, then include .bash rc. So this is saying, well, if we've got a bash profile, then we can do it, but if we're in bash, we can include bash rc. So then I can, just run bash rc. And so this seems to be saying we can create .bash profile, or we can create .bash rc. Now I'm going to just create .bash rc, because that will jive with the rest of the system. And we can see that this file is here already because there's stuff in it and that kind of thing when I went to edit it. So there's a lot of interesting stuff going on here. Set a fancy prompt. Setting the color prompt. This is starting to make sense. It's like, oh yeah, we've got a color prompt, and then some color stuff happening here. And, get some stuff there. Enable color support of ls, and also add some handy aliases. Oh, now here's some interesting things. Alias dir, grep to be grep as color, fgrep and egrep. Grep. That's not foreshadowing at all. Some other stuff going on here. If bash aliases, then do some stuff. Like you may want to put all your additions into a separate file like bash aliases instead of adding them here directly. See user doc bash docs example. So on a Debian system, we'll add them to bash aliases. That sounds fine. Okay. So now we might want to do alias ll equal ls-l. And then to make that take effect immediately, we can do .source.bash alias. And if we open a new terminal window, you can see that LL works fine. Now if we come over to our Red Hat system, let's begin by just typing alias. We can see we've got a lot more aliases out of the box by default with Red Hat than we do on Debian. And we can see, look, VI is automatically aliased to Vim, and then we've also got an alias for which, and we can see that we already have an alias for LL, and so that came from somewhere on the system. Did that come from our home directory? No. If we do bash rc, it's like, okay, there's nothing there. Do .bash profile _profile. You can see there's nothing there, and if we look, it doesn't look like there's anything else here with that. But it does say, okay, it'll execute bash rc, and we have bash rc here. And so this says if exists, etc. bash rc, then run, etc. bash rc. So let's less, etc. bash rc. Okay, system-wide functions and aliases. Environment stuff goes in /etc/profile. Okay, so are we in an interactive shell? There's a lot of fun, interesting things happening here in this. This is incidentally a shell script. This is a little more complicated. You can see that we've got, you know, if and branch logic and all sorts of fun stuff going on here. And remember we saw the alias for VI being alias to Vim. If we less etc. profile.d vim.sh, we can see here on the last line, you know, this is a fairly complicated way to do it, but it's going to alias VI is equal to Vim, you know, depending on which command interpreter you're using. But these shell scripts are written in such a way that it'll tolerate, you know, are you using bash, are you using k shell, are you using z shell? And because of that, it adds all of this complication here. And so I don't think for your introductory course we need to worry about that. If you're feeling especially precocious, by all means, read the documentation and understand all of that stuff. Not really a big deal. But for now, we don't really need to create an LL alias on Red Hat. So let's alias L2 just for giggles. So if I do L2 command not found .bash rc, so we'll run the stuff from etc. first, and then it says user specific aliases and functions. Most systems leave you a hint of where you should put stuff. So we're going to do alias ls equal, or I'm sorry, L2 is equal to ls-l. We run L2, see nothing has happened. If we do source bash rc, well, now I'm not going to run source on this terminal. I'm just going to make a new terminal window. I'm going to close out my little warning messages from VirtualBox. Then if I do L2, everything's fine. Source just runs it right now. That's all it does, because this normally doesn't run every time you change it. It's just every time the shell is created, every time you log in. So do source there, and then I can do L2 here, and it works fine.